Welcome. Coral Reef Aquarium School Basic. Today is our 6th episode and we will be talking about water movement and flow. We will start this episode by me giving you a word of advice. Don't underestimate the importance of water movement and flow. I think when you start reading up and listening into discussion, I think you will notice there's a lot of discussions and opinions about light. And I think water flow gets in the shadow of the light. So don't underestimate this. This is very important. Why is flow so important? First, corals are stationary and sedentary, so food and nutrients need to come to the coral and waste and detritus has to go from them. Secondly, flow oxygenates the water and removes CO2, which is very important. Now, how do you create flow in your aquarium? We will be talking about 4 types of simulations of flow. And the first one being stream. I will refer to this as stream, but sometimes it's referred to as laminar flow. And how do you create a stream? You have a single or you have multiple stream pumps or maxi jet pumps, and they're directed into the water, in the open water. And the results of that is that you will create a unidirectional steady state flow. And if you have that flow in the directed in the vicinity of corals, you might risk long-term tissue damages. And actually, this type of flow, I think most frequently the pump is better used to create turbulent flow, which is a second flow simulation. So, what is then turbulent flow and how do you create turbulent flow? You direct a power head, a maxi jet or a stream pump onto a rock, the glass or even the water surface. And you can actually also take 2 pumps and direct them at each other, have them collide. So the result is that the flow will reflect and the reflection will be random. So movement in the water will vary. And that is very beneficial for corals and fish and your system. So that's very, very good. Continuing on good, we have our third flow simulation, and that one being the wave. Sometimes it's referred to as surge. How do you create the wave? Yeah, most easily you have 2 opposing pumps and you have them alternate. So one pump is engaged, pushing the flow in one direction, and then it shuts off, and the second one turns on and pushes it in the other way. There's an alternate to this, and that is using a wave box. So that's basically installing a box with a pump, and the pump is alternating. So it starts by engaging and it's emptying the wave box. So then your tank is filling up with more water, and then the pump goes off and the wave box is backfilled. So then you can get a very powerful wave in your tank as well. And that's also beneficial. Fourth, we call the 4th type, typically it's referred to as the gyre flow. And then you have 2 longitudinal centrifugal pumps and you install them diagonal to each other. And the result of that, typically these are also speed controlled or oscillating. The result of that is that you create a very strong rotational flow in your aquarium, and that will move a lot of water. Also very beneficial. Okay, some additions to flow and pumps. Advanced flow pumps, they typically come with speed control, and then you're able to create various oscillations in your tank, and that is very beneficial because the natural environment for the corals is very oscillating or random. Secondly, you don't have to go with one flow type. Utilize multiples or all flow types if you can. This will depend on the tank size, because the smaller tank you have, the more difficult it will be to utilize all flow types. But they're all free to use. Thirdly, surface agitation or small waves or ripples on the surface. That is very beneficial to drive out CO2 from the tank, and driving out CO2 will help you keep your pH level up of the tank. And it will also oxygenate the water, having the surface agitation. So make sure to invest a little bit of flow on the surface of your aquarium. Finally, on the additions, this is a little bit difficult, but 5,000 liters per hour from one brand in a flow pump may be totally different to 5,000 liters per hour from a second brand. There's no good standardized test method in the aquarium industry to how you should test stream pumps and put flow numbers. So it can vary a lot in your tank. And we have to live with that. Okay, how much flow do you need? I will give you a blunt rule of thumb. And the last time when we talked about circulation flow, I gave you a crude rule of thumb. Blunt is even worse than crude in my world. And the rule is stating install 100 times the display tank volume per hour. And this is installed capacity. It doesn't mean that you're going to utilize the full 100 times instantly, at least. So if you have a 100 liter aquarium, that means installing 10,000 liters per hour of flow. And this is also including the circulation flow. So you add that on top. But this rule of thumb being blunt, I will also post it with a warning. 9 out of 10 first attempts to go for 100x will create a sandstorm in your aquarium. So how do you avoid a sandstorm then? First, you start with caution, starting installing 25 to 50x the display volume. Or you install speed control pumps and you set them to 25%. Then you go for multiple pumps, not one single. That will make your life a lot easier. But this also depends on the tank size, because smaller tanks could be difficult to install multiple pumps. They will take up too much space. Thirdly, if you have a speed control, you increase the amplitude or the speed control and also the oscillations to increase the flow and increase the movement in your tank. And doing so, you evaluate the coral polyp expansion and the tissue behavior of the corals. You look also in your tank for dead pools and where do you get the detritus and waste to build up, and try to remove it. Now, if you target or try 100x, I will also advise that you get pump system with a night mode, because my experience is that corals are typically more sensitive during night when the light is off. So if you have strong flow, strong currents, it can easily accumulate the tissue damage. And also get a feed mode, so you can speed down the pumps when you're feeding your fish. Why you want to do that is that you don't want to feed your fish and all of the food is taking into the filtration. So then you're only filtering out the food and it's not benefiting the fish. Secondly, on 100x, give it a few years, settle for 25 to 50x in the beginning and get the hang of it, and then try pushing the upper boundary from there. Okay, so how do you read your aquarium? If you have too high, too low, or adequate flow. Too high, typically one sign is that you get poor polyp expansion. Typically when the light goes on in an aquarium, the coral inflate and polyps come out. And if you don't see that one, maybe you're stressing it with too high flow. Secondly, you can get that the coralline skeleton is always visible to the coral tissue. I mean, the tissue is stretching or it's even receding. That's also could be a sign of too high flow. Thirdly, you can see tissue damage on the stream side. And finally, another sign is that the sand is always shifting and it's not resting in your aquarium. Then it could be a sign that it's poorly directed or it's too high. Signs for too low flow for instance, the detritus are left on corals, like some of the LPS corals, like Ephobia, because it needs flow to get the detritus off it. And similar on rocks and sand. You see detritus building up and it's not moving out of that area. So you also have identifiable dead areas where the detritus can collect for a long time. Okay, and then finally, how do you know what's adequate? Yeah, adequate is if you get waste or detritus, you can suspend it in the water column long enough so a significant portion of the waste is moved into the filtration flow, the filtration chamber. It's very difficult to get all, but a significant portion of it. And you have only a few dead spots left in your aquarium because you will not get rid of all. Finally, food is not pushed out directly of the tank because you want to avoid that as well. Final word here, also make sure clean pumps every 6 or 12 months to keep the performance, and re-evaluate your settings as the reef grows, maybe a few times per year if you need to pick up speed. Typically, as your corals grow, flow will reduce and you need to increase amplitude a little bit on your pumps. Okay, that said about flow. In our next episode, we will move into temperature and temperature control. And that said, I thank you for your attention. And we will do as we usually do. We will move into the project phase where we talk about what pumps we will be using for the project tank. And I hope I see you there. Okay, for the project part, we'll be using this pump. It's an aquarium system MaxiJet Wave 2000 pump. So it's rated at 2000 liters per hour. We've already installed a circulation pump at 300 liters per hour. So the total flow we're circulating in the display area is 2300 liters rated. Now the tank is sized 36 liters, but actually if you measure the actual water volumes, I have 23 liters in the display and about 7 liters in the filter. A total of 31 liters, so less than 36. But on the display then 23 liters and then 2300 liters of flow. The ratio I will start at is 100x. It's a little bit too high to what I'm comfortable with, but I know that this pump, I've had it before and it is in the weak side of 2000 liters per hour, so I actually think it's going to work quite well. Okay, I will not shoot a video when I've installed it in the aquarium. I will just move into a picture now for this video. And as we look at the installation, I will also thank you for your attention, and I hope you stay tuned to our next episode on temperature control. Now, bye bye and have a good evening.